Hey everyone, thanks for watching today's video where we're going to talk about some common theorems, properties, and definitions for triangle proofs. So, like we've talked about in the past, we're going to have to prove two triangles are congruent, and there's certain rules and theorems that help you do that. So we've gone through kind of the combinations that allow you to say two triangles are congruent. So side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. So I'm not going to go through those so much this time, but sometimes we have to use these other rules to get to where we can use those combinations. So these are kind of the precursor to those other rules. I know we went through the other rules first, but it's important to kind of understand what we're trying to get to before we think about how we need to get to it. So these are the common rules. So the reflexive property, when a quantity is equal or congruent to itself, used for shared parts. Let me show you an example of when that would come into play. So let's say I have a triangle here, and then I have another triangle here, and you're setting up your proof, and you need to prove that the two triangles are congruent. You're given this, maybe these two angles are congruent, and you're given these angles are congruent. Well, you need that side in the middle. So what you would use is you'd use the reflexive property and say, well, they share the same side. So you would say, so that side is equal to that side, and that's because of the reflexive property. So it sounds like a weird one. A quantity is equal or congruent to itself. Of course it is. It's just something you need to write down when you're doing proofs to kind of just make sure that you write it out before you put it in your side angle side combination. So transitive property, when two quantities are equal to the same quantity, they are equal to each other. So what does the transitive property look like? Well, A equals B, B equals C. So what lets me say that A equals C? That is the transitive property. So A equals C, and your reason would be transitive property. So that is what that is for. I know that can sound weird too, so I recommend you write down these examples because they really bring the rules to light and help you understand them a little bit better. So transitive property is what makes that true. All right, next one. Angle bisector. So a ray in the interior of an angle creating two congruent angles. So what that means is, if this is often given, so they would say it's an angle bisector. So maybe a ray is an angle bisector. So ray PQ is an angle bisector. Let me make that Q a little better. And you have to be able to interpret what that means. So what that means is that it cuts the bigger angle. Let's make this MPR or something. It cuts MPR into two equal sides. So what the angle bisector of PQ does, it makes that congruent to that. So the angle bisector cuts the bigger angle into two congruent angles. So that's an important one as well. All right, so segment bisector, same exact idea here. When you see bisector, just think, okay, we're cutting it into two equal parts, and that'll get you pretty far. So let's say we have a segment here. Make this A, B. Then we're going to put point C in the middle, and if it's a segment bisector, so it's a line, segment, or ray, so it could be something like this. Let's just make it a line here. Line C, that's going to cut, so AC, segment AC, is congruent to segment CB. And that is because C was an angle segment bisector. It cuts it into two equal parts. So again, a pretty intuitive one. If you know angle bisector, segment bisector should come pretty naturally. All right, so on to the next one. We have a median of a triangle. That's a segment from any vertex of a triangle to the midpoint of the opposite side. So let's think about that for a little bit. So we've got a triangle. It says a segment from any vertex of a triangle to the midpoint of the opposite side. So a segment on any vertex, let's start here, and it's going to the midpoint on the opposite side. Well, the opposite side is obviously here, and the midpoint must be there. So what that implies is that if I say, let's make this triangle A, B, C again. Let's say BD is a midpoint. So that's what they told us. BD is a median. I mean, not a midpoint. BD is a median. What we can infer through the median of a triangle, the definition of a median of a triangle, is that AD, that segment, is congruent to segment DC. That's because it says that it goes to the median of the opposite side. If it's in the median, that means half of it's here, half of it's here. Those two segments are equal. So that's what we can use medians to help us out with. Okay. So now let's think about the next one. We have the altitude of a triangle, a segment from any vertex of a triangle perpendicular to the line containing the opposite side. So perpendicular to the line containing the opposite side, let's draw a triangle again. So a segment from any vertex, so let's go from this one, and it's going to be perpendicular to the line containing the opposite side. Well, the opposite side is this, and we need to be perpendicular. Remember, what does it mean to be perpendicular? That means it creates right angles. So that helps you figure out that, okay, well, this angle must be congruent to this angle. If I tell you that this line, let's make ABC again. If I say AD is a altitude of the triangle, then you would be able to say, okay, well, angle BDA is right and angle ADC is right because it's perpendicular. So that's knowing the definition of perpendicular and the definition of an altitude of a triangle. So that's a good one to know as well. You don't see that one as much, but you do occasionally. Okay, the linear pair postulate. So this says two angles form a linear pair if the angles are adjacent to the end the two unshared rays form a line. This theorem says that two angles that form a linear pair are supplementary. So the angles are adjacent and the two unshared rays form a line. So what that means is that you have a line here and then you have a ray going like this. I know it sounds really confusing, but that's all it is. It's a straight line and then some ray going off. And all the linear pair postulate is saying is that if this is 30, this must be 180 minus 30, so this must be 150 degrees. And that's because of the linear pair postulate. We would say that those two form a linear pair. This one is one you see a lot, and adjacent means angles are next to each other, and this angle is indeed next to this angle. They're right next to each other, and a straight line connects them. Okay, so now rules regarding parallel lines. If two parallel lines are cut by a transversal, alternate interior angles, exterior angles, and corresponding angles are congruent. This is an important one and really has a lot of rules put into one. So let's draw it out here. So we have a transversal. So these are parallel lines, these two here, and then we have a transversal. And it says the alternate interior angles. Alternate interior angles are exactly what you think they are. So interior means inside the two parallel lines. So that's going to be these angles here. So this one, this one, this one, and this one. And it says alternate interior angles are congruent. So if I have this one, its alternate angle is going to be on the other side. So that's that one. It says that angle is congruent to that one. And this one is going to be congruent to this one. So let's draw the two dashes for those. Okay, so that's what the alternate interior angles are. So alternate, think opposite side. Interior, think inside the two parallel lines. All right, let's go to the next one. I'll just have to redraw that line. Okay. So now it's going to say exterior angles, alternate exterior angles are congruent. So now if we have an angle here, and so exterior means outside of the parallel lines. So now it's on the other side of the parallel lines. Well, the alternate side, like we said, means opposite side, so that must be this side, and it says that those are congruent. So now let's do the other one, which would be these two, and this one. So those are also congruent because those are also alternate exterior angles. Now the last one is corresponding angles, and this one is pretty intuitive. So corresponding, just the word in general means that it's kind of like similar, so that's what they are here. They're kind of like four angles here, that 1, 2, let's name them actually, 1, 2, 3, 4. So 1, 2, 3, 4, and then here I'd have 5, 6, 7, 8. The corresponding angles for 1, 2, and 3, and 4 are kind of the 5, 6, 7, 8 angles that are in the same spot. So corresponding angles would imply that 1 is congruent to 5. See how they're in the same spot on the opposite parallel line. Then angle 2 is going to be congruent to angle 6. Angle 3 is going to be congruent to angle 7. And angle 4 is going to be congruent to angle 8. So those are corresponding angles. So that's the last of the parallel lines. So the rules regarding parallel lines, these are really important actually. You see a lot of those, so I definitely recommend you know that. And this last rule, very important, you use it all the time. Corresponding parts of congruent triangles are congruent. So this is something that you see later on in proofs. So first you use all the rules that we just talked about to help you prove one of these combinations. So you get to one of those combinations, you've proved that they are congruent, and then you can use this rule to prove other things about the two triangles. So the corresponding parts of congruent triangles are congruent. So let's say, and obviously what it means is exactly what it says. If two triangles are congruent, all of the corresponding parts, angles, and sides are congruent. So let's say we have A. We've talked about this a little bit in other videos, but I just want to show you what it really means. And then we have D, E, F. So let's say we've proven that they're congruent by this theorem. So angle, side, angle. So we've used those and we've proven all of those. But then how can I prove C is congruent to F? Well, by the corresponding parts of congruent triangles are congruent. So now I could say angle C is congruent to angle F, and the reason would be this. Because even though we didn't prove it strictly when we were proving the two triangles are congruent, we can now step aside and say, well, that means every part of the two triangles has to be congruent. And that's because of this rule here. The corresponding parts of congruent triangles are congruent. Okay, so hopefully that makes sense. I hope you took notes while we were doing all that. I know it can be a lot of stuff. There's a lot of rules, and these are really important because you can't really solve all the proofs without them. So now let's just talk about some tips, and then in the future videos we'll actually get into doing some. So it's always a good idea to draw and mark your diagram before beginning. If it's not already drawn out for you, 100% you've got to draw it out. And then what I mean when I say mark the diagram is that if it says A is congruent to C, just mark that. So mark your little dashes and write that in, because that'll help you kind of picture it and see what you're dealing with. Second tip, look for any shared parts of the two triangles. Those will all automatically be congruent by the reflexive property. This is like we talked about right at the beginning. So if you have a triangle like this, and then another triangle on the other side, a good first step is to say that that is congruent to, like this angle is congruent to, this side is congruent to that side because they're shared. It's just a good step. It often will help you out with the proof. And lastly, you got to remember these definitions that we just talked about. These are usually the tips that are going to help you get to the next step. A lot of proofs start off with, you're going to be stuck and you're going to be thinking, well, what can I prove? What can I prove? And usually one of these tips is your next step. It's usually, oh, I need to use the reflexive property. Oh, I can use transitive here, or something like that. So really important to know these rules, commit them to memory, take notes on them, take a picture, I don't know, whatever you want to do. But these are important rules, and because they help us get to our overall proof, which is one of these combinations. So hopefully this is a good introduction. Sorry if it's a little confusing at first, but as we get into proofs, I'm sure you'll start to understand them better. Let me know if you have any questions, and thanks for watching.